This video is on Unit 1, Chapter 3, Systems of Equations, Lesson number 3, Solving Systems, 3-Variable Systems. So in this video, we are still working on solving systems of equations, but in this lesson, what you're going to see is 3 different equations and 3 different variables. And the steps that we're going to use to solve that system are listed here. So step number 1 says to choose 2 equations in which you can easily eliminate a variable. Let's call this new equation after the elimination equation A. Step number 2 says to eliminate the same variable from a combination of the equation you didn't use and one of the ones that you did. Let's call this equation after the elimination equation B. Thirdly, you want to put the equation A and equation B together and solve that system. You now have 2 of your variables. Then fourthly, you're going to substitute your answers from step 3 into either original equation to find the remaining variable and then write your solution as an ordered triple. So you know in an ordered pair, it's X and a Y. So that's an ordered pair because there's 2 of them. In a 3-variable system, you have an x-axis and a y-axis and a z-axis. It creates like a 3D kind of thing. So your solution is a point in space. So we're looking for where these 3 lines intersect in space. Now, just like with 2-variable systems, there are going to be times when your 3 lines don't all intersect at the same point. And you can end up with no solution. We can also have infinite solutions, just like you do with 2-variable systems. So looking at example number 1, you've got 2x minus 6y plus 9z is equal to negative 8, 5x plus y plus 2z is equal to 10, and 3x plus y minus 8z is equal to negative 28. So when I look at these 3 equations, step number 1 says to choose 2 equations in which you can easily eliminate a variable. So I'm looking at equations 2 and 3. So I'm going to call this one equation 1, equation 2, and equation 3. So if I'm looking at equation 2 and equation 3, I know I can easily eliminate the y variable. And that's what I would do. That's an easy process because they both have the same coefficient in front. They both have a coefficient of 1. So I'm going to focus on the y's, and I'm going to take equation 2 and equation 3, and I'm going to eliminate the y's. To do that, I'm going to take one of those equations and multiply by negative 1. I'm just going to take equation 3 and multiply everything by negative 1. Using equation 2, and then multiply equation 3 by negative 1. That would be minus y before I make a mistake here. So minus y plus 8z equals a positive 28. So again, all I did was I took that equation 3 and I multiplied by negative 1. Now when I add these 2 together, the y's are going to go away. So 5x plus negative 3x is a 2x plus 2z plus 8z is 10z equals 10 plus 28 is 38. Now that's going to be equation A. Okay? Now in step 2, it says to eliminate the same variable. So because I eliminated the y's in my first step, I have to continue with eliminating the y's, and I'm going to pick 2 different equations. So I'm going to pick equation number 1 and equation number 2. You could easily pick equation number 1 and equation number 3. That doesn't matter. But because I did not use equation number 1 to start, I have to use equation number 1 now. I'm going to keep equation number 1 as it is. And I'm going to use equation number 2, and I'm going to multiply equation number 2 by a 6 so that the y's will eliminate. So 5x times 6 is 30x. 1y times 6 is a positive 6y. Positive 2z times 6 is a positive 12z equals 10 times 6 is 60. And now I'm going to add these two together. And what happens is, again, the y's are going to eliminate. 2x plus 30x is 32x. 9z plus 12z is a positive 21z equals negative 8 plus 60 is a positive 52. And that's equation B. Now, what you have just done in that process, once you got equation A and equation B, you have a two-variable system. So using equation A and equation B, you're going to use the methods that you learned in lesson number 2 to finish solving the system. So looking at equation A and equation B, I would probably eliminate the x's. Equation A has a positive 2x. Equation B has a 32x. If I multiply equation A by negative 16, I can create x's that will eliminate. So let's do that. I'm going to multiply equation A by negative 16 and put it underneath equation B. So 2x times negative 16 is a negative 32x. Positive 10z times negative 16 is a negative 160z. And then 38 times negative 16 is negative 608. Now I'm going to add. And again, I did that so that the x's would eliminate, and they do. So now I've got 21z plus negative or minus 160 gives me negative 139z equals 52 minus 608 is negative 556. And then we're going to divide by the negative 139 and get z equals 4. So that's one of the three variables. That's one part of my final solution. I'm going to take that z equals 4, and you go back baby steps. So you're either going to take that to equation A or equation B and substitute that in to find your second variable. I'm just going to go ahead and use equation A since I've got room. Plus 10 times z is a 4 equals the 38. So 2x plus 40 equals 38. Subtract the 40. 38 minus 40 is negative 2. Divide by 2 and you get x equals negative 1. Now, to find the y value, we have to go back to one of the three original equations. And it doesn't matter. The solution to the system is the point where they all hit each other. So whatever your solution is going to be true for all three. So I'm going to pick the first one. X is negative 1, so it's going to say 2 times negative 1. I'm looking for y, so leave minus 6y, plus 9 times z is 4 equals negative 8. So 2 times negative 1 is negative 2. Minus 6y plus 36 equals negative 8. I'm going to combine the negative 2 and the 36 and get 34. Then I'm going to subtract the 34. Negative 8 minus 34 is negative 42. And then divide both sides by the negative 6 and you get y equals 7. So to put that answer together, it's x, y, z. So x goes first, then the y, and then the z. So that's your answer for problem number 1. Let's jump over to question number 3. question number 3. Looking at the 3 equations, again, the beginning step is to pick the variable that you think you can eliminate pretty quick and easy. And in this one, I think the z's are going to be the easiest one to eliminate. So I'm going to use equation number 1 and equation number 2 to eliminate the z's. And I'm gonna leave equation number 1 alone, and I'm gonna multiply equation number 2 by an 8. So the first one is 5x minus 3y plus 8z equals negative 59. And then multiplying the next one by 8. So 9x times 8 is 72x. Negative 4y times 8 is negative 32y. Minus 8z equals negative 60 times 8 would be negative 480. And then we're going to add those two together. And again, I chose the z's because they were easily eliminated. Now I know the numbers are big, but that's okay. Now I'm going to add 5x plus 72x gives me 77x. Negative 3y plus negative 32y is a negative 35y. The z's are gone. And then negative 59 plus negative 480 is negative 539. Okay, so that's equation A. All right, so from there, I'm going to continue to use equation 2, but because I didn't use equation 3, I need to use that one. So using equation 2 and 3 this time, the z on equation 3 is a 4, so I'm going to multiply equation 2 by a positive 4 so that the z's are going to eliminate. So again, equation number 2, 9x times 4 is 36x. Negative 4y times positive 4 is negative 16y. Negative z times 4 is negative 4z equals negative 60 times 4 is negative 240. This equation 3, I'm just going to bring that across. The trick is making sure that you eliminate the same variable to get equation A and equation B. If you make a mistake and you eliminate, say the x is in one and the y is in the other, you've just created a mess. So it's important that you do eliminate the same variable both times. So 36x plus 5x is 41x. Negative 16y plus 2y is a negative 14y equals negative 240 plus negative 47 is negative 287. And that's equation B. Okay, so here again, the hard part at this point is saying, okay, do I want to eliminate the x's or do I want to eliminate the y's? And I'm thinking the y's are going to be your best bet. So 35 and 14 have a 7 in common. There's a common factor of 7. So I'm thinking I can get away with multiplying by something smaller than 14 and 35. Because, okay, so if I take, let me do this in a different color. If I take 35 times 2, I get 70. Does 14 go into 70? Yes, it goes 5 times. So I'm working towards a 70y. I'm going to eliminate my y's, and I'm going to do it by making one of them a positive 70y and one of them a negative 70y. Well, equation A, if I multiply that by 2, I can get a negative 70. If I multiply equation B by a negative 5, because negative 14 times negative 5 is a positive 70. There's my positive 70. All right, so let's do this. 77 times 2 is 154x minus 35 times 2 is going to be my minus 70y equals negative 539 times 2 is negative 1078. Okay, that's my new equation A. Equation B is going to multiply by negative 5. 41 times negative 5 is negative 205. And then negative 14y times negative 5 is a positive 70. And there they are, my matching y's, or my opposites. And then negative 287 times negative 5 is going to be 1,435. And we can add, and the y's go away. So now I've got 154 plus negative 205 gives me negative 51x. The y's are gone. Negative 1,078 plus 1,435 is 357. And divide by negative 51. And we get x equals negative 7. All right, so again, from there, back baby steps, you're going to go back to either equation A or equation B and substitute that in. I'm going to use equation B because the space is here. So x is now a negative 7. And when I solve this, I will end up with the y value. 41 times negative 7 is negative 287. Equals negative 287. So now I'm going to add 287. Negative 14y is equal to 0. Divide both sides by negative 14. You get y equals 0. It doesn't go away. The y is still there. You still have a y value. So y equals 0. So I have the x. I have the y. I need to find the z. I'm going to plug that into one of these three original equations. Pick one. I'm going to use equation number 1. X is negative 7, so I've got 5 times negative 7 minus 3 times y is now 0 equals negative 59. So negative 35, that's going to be 0, plus 8z equals negative 59. I'm going to add the 35. Negative 59 plus 35 is negative 24. And then divide by 8 and you get negative 3. So your final answer is negative 7, 0, negative 3. All right. So we do need to look at some word problems. I'll go through one of these. I might set up 2 of them just so that you can see the process for setting it up, but I'm only going to solve one for time's sake. So question number 6 says the theater sells 3 types of tickets: general admission, senior citizen, and child. Mark bought 9 general admission, 2 senior citizen, and 3 child tickets and paid $170. Sarah bought 5 general admission, 4 senior citizen, and 7 child tickets and paid $173. And then Kyle bought 4 general admission, 1 senior citizen, and 6 child tickets and paid $116.50. Find the cost of each type of ticket. So I'm going to put general as my X, and then senior citizen as my Y, and then child as my Z. And again, what you're trying to find here is find the cost of each type of ticket. So this represents a dollar amount. Okay. Now, the thing about these, setting these equations up is each person gives you an equation. So Mark, for example, bought 9 general admission, 2 senior citizen, and 3 child tickets for a total of $170. So your equation is very easy. It's 9x plus 2y plus 3z equals $170. The second equation is going to come from Sarah. Sarah bought 5 general admission, 4 senior citizen, and 7 child for $173. And then Kyle would be our last equation. Kyle bought 4 general admission plus 1 senior citizen plus 6 child tickets for a total of $116.50. Now, the process for solving is exactly the same as the process that I just went through for the other 2 examples. The exact same process. Looking at these 3 equations, I would probably eliminate the y's, and the biggest reason is because of that one y. I can use equation number 3 and both times, and the y's will eliminate pretty easily. So let's do that. Let's take equation number 1 and equation number 3. So I'm going to multiply equation number 3 by a -2. So taking equation number 1, and equation number 3, multiplying by -2, 4x times -2 is -8x, minus 2y, minus 12z equals 116.50 times -2 will be -233. And then I'm going to add the 2 equations together, and the y's will go away. 9x plus a -8x is a 1x. 3z plus a -12z is a -9z equals 170 plus -233 is -63. And there's my equation A. And then I'm going to I'm still using equation number 3, but I didn't use equation number 2. So I'm going to keep equation number 2. But now I'm going to multiply equation number 3 by a -4. And by multiplying this by a -4, that will eliminate the y's again. So 4x times -4 is -16x, minus 4y minus 24z equals 116.50 times -4 is -466. And add. 5x plus -16x is a -11x. The y's again are gone. 7z plus -24z would be a -17z equals 173 plus -466 is -293. And that's equation B. Now, looking at equation A and equation B, I'm thinking the x's are going to be the easiest to eliminate. And again, the reason for that is because of this 1 on the x. If I multiply equation A by 11, the x's will go away. So let's finish that out here. Multiplying equation A by 11 and lining it up underneath equation B, I will have 11x minus 99z equals -693. And when I add, the x's are going to go away. -17 plus -99 is -116z. And then -293 plus a -693 gives me -986. And then divide by -116, and we get $8.50. And that's the child ticket. So the price of a child ticket is $8.50. Now we need to take that back into, I'm going to go back to equation A and substitute that in. So x minus 9 times 850, negative 9 times 850 is 76.5. And then negative 63 plus add your 7650. And we get 1350. So those are the adult tickets, I think. No, the general admission. General admission is going to be the $13.50. Child tickets are $8.50, and then we have to figure out how much are the senior citizen tickets. And to do that, you go back to one of those three original equations and plug in your x and your z. So I'm just going to pick up, and it looks like I'm kind of out of room here. I'm going to use equation number 1, plugging in my x. So 9 times 1350 plus 2y, I don't know what that is yet, plus 3 times z was 850 equals 170. So then solve. 9 times 1350 is 121.50 plus 2y. 3 times 850 is 25.50. And then I'm going to combine the 25.50 and the 121.50 to get 147 equals 120. I've done something wrong. Oh, that's 170. Sorry for that little moment of silence. I had written this and I couldn't even read my own handwriting. This is not 120. This is 170. So sorry, y'all. I knew something wasn't turning out right because I was going to end up with a negative value there. So now when I subtract 147, 170 minus 147 is 23. And then divide by the 2, and you get 1150. So the general admission is 1350. Senior citizen tickets are 1150. And your child ticket was $8.50. All right, so there's that problem. Real quick, I want to show you how to set up one like number 7. I'm only going to set this up. I am not going to finish it. It says Jamie has a collection of 78 nickels, dimes, and quarters worth $12.40. If the number of quarters is doubled, the value becomes $22.15. How many of each type of coin does Jamie have? How many of each coin? So if we let X be how many nickels? And Y be how many dimes? And Z be how many quarters? That's going to help us get this set up. We know he has 78 total. So the number of nickels plus the number of dimes plus the number of quarters is equal to 78. Now, a lot of kids want to take x plus y plus z equals to 1240, but you can't do that because x doesn't represent a dollar amount or a money amount. It represents how many nickels. So in order to set it up so that it's equal to a dollar amount, like $12.40, I have to take each one and times it by what it's worth. So a nickel is 5 cents, so 0.05x. Dimes are 10 cents, so that's a plus. 0.10 cents. And quarters are worth 25 cents. That's going to give you the money. Now, the last equation comes from that last part. If the number of quarters is doubled, the value becomes 2215. So what am I going to do to this equation to now make this 2215? Well, the nickels are not changed. The dimes are not changed. But I have double the amount of quarters. So 2 times 25 cents is going to be 50 cents. So that's going to change that to 0.50z. And then you would go from there, doing the same process. Obviously, when you're talking about this type of word problem, it is a lot longer and a lot more drawn out just because of all of the decimals. But again, the process would be the same to solve that. If you take the time to do that on your own, I can tell you that there are 25 nickels, 14 dimes, and 39 quarters. So that is the final answer to question number 7. And those are your notes for a 3-variable system for lesson number 3.